So I guess we can start. My name is Rafael. Just a quick intro. I started working for the Swarm team last September, but it was really just part-time, 1 day per week. And then I started working actually then mostly full-time from beginning of the year for the Swarm team, mainly focusing on the DevOps aspects of the project, so infrastructure related. With me, I have Anton. He's with the Swarm team now for like 1.5 years, 2 years.
Yep. Hello, everyone. Yeah, I've been with the Swarm team for the past 1.5 years, and yeah, also doing foundation-wide DevOps work. And yeah, let's start. So first, a short recap about observability in Swarm. So basically, the tools that we have available to help us develop, test, and monitor Swarm so that we can achieve our vision. And this is the logs, metrics, and the tracing. So basically, Swarm is sending logs to standard output and standard error, as you all know. You can set the verbosity, the debug, and basically see where debug lines come from. And we're using Kibana and Elasticsearch to aggregate our logs, which helps us to debug issues and monitor our nodes that we maintain as part of the public testnet. About metrics, as you know, also you can expose metrics from your Swarm node, and we also collect those and aggregate them, and they scale much better compared to logs. So the more nodes that you add, like the metrics don't really explode. And we use InfluxDB and Grafana to visualize those. So on this screenshot, you see the peer-to-peer dashboard that we have, where we measure all the peers different nodes have, the total number of peer-to-peer messages sent, and also the individual messages sent as part of different protocols like PSS, Stream, Hive, etc. So you can have an understanding of what individual dev P2P protocols do within Swarm. And we also have tracing. We have instrumented the code base with the OpenTracing library, which we use together with Jaeger to visualize traces. And this is how it looks basically. So with Jaeger, you can actually see requests going from one node to another, and also monitor and see how nodes communicate with each other. In this screenshot here, you can see basically an HTTP GET request for a piece of content, and every lazy chunk reader read is basically either getting data from the local store on your local node, or if you don't have the particular chunk, issues a remote request. And you can see in this screenshot that a node basically does 2 hops to fetch the content that it needs. So now I'm going to talk about how we actually run Swarm as part of the team to help us develop it, where we are coming from, and how we came up to the current system, and basically why we built it. So previously, when we were developing Swarm, we had pretty much the only possibility of running Swarm in small deployments. So as a day-to-day dev, you would basically run a bunch of nodes on your local machine, and you can interact with them through the simulation framework. But yeah, and within the public gateway that we maintain for the community, we had a bunch of static virtual machines, which were running a static number of containers on them, so that you can try Swarm without having to run your own node. That's the swarmgateways.net. And these were all managed with Terraform and Ansible playbooks. The issues that we had with all this was that for small test deployments on your local node, basically you're limited by the resource limitation of the machine, and you can't really run large-scale deployments, let's say 100 nodes, because you just don't have that much power on your machine. And some problems manifest only when you run larger deployments. I mean, if you want to test Kademlia topology and syncing, you need at least like 15 to 20 nodes so that you build a somewhat healthy Kademlia topology. If you just run 2 nodes, you're not running half of your code base, basically. Also, simulations are kind of hard to debug. You cannot really interactively inspect them after they have completed. I mean, this is not part of the code base right now and something that we want to improve in the future. And in terms of the public gateways, it was very time-consuming and hard to scale them up and down. Basically, they were mostly static with virtual machines provisioned with Ansible playbooks. And yeah, that was a problem. So I'm handing over now to Rafael, who was very instrumental in bringing the new setup, and he's going to talk more about where we currently stand and what we want to improve in the future.
Thank you, Anton. So as Anton mentioned, the previous setup was pretty static. Scaling up things was very difficult. And we had also the goal that we wanted our developers to easily spawn up, I don't know, 100 Swarm nodes and observe what's happening in this network. So on this slide we have a list of tools that we are using. I mean, InfluxDB and Grafana, we used this already in the past for the metrics. Jaeger, Anton already mentioned it, this is for the tracing purposes. So these are things that we had already. What we didn't have was a proper orchestrator to deploy our workloads. So for that we started using Kubernetes. We previously already were using like Docker containers, statically deployed on some VMs. And Kubernetes gave us like the benefits of having a pool of worker virtual machines where we can just deploy our 100 node Swarm cluster and don't care about saying, oh yeah, this should be running on this machine or that machine. The orchestrator will deal with this problem for us. Another thing related to Kubernetes that we are using is Helm. Helm, you can see this like as a package manager for Kubernetes. So it includes all the resource definitions. So everything you want to deploy within Kubernetes inside like one package. I will show you like briefly, for example, what a Swarm Helm chart looks like. And then Anton already mentioned this. We started collecting logs. So once you have like a system like this running containers everywhere, it's very useful if you have a centralized place where you can visualize your logs. So for that we use Elasticsearch, Kibana, and FluentBit. And we also, so once you deploy like a 100 node cluster, you want to like run some basic smoke tests on it to like make sure that the most important functions of Swarm are working. So now back to this Helm chart. So as I mentioned, the Helm chart, you can see it as a package, like a group of applications, like things that are going to be deployed within Kubernetes. I'm not going to talk that much about Kubernetes details. I think that's not important for this talk. But within Swarm, so this Helm chart, we have, of course, Swarm itself. It might be important to reference that like the minimum deployment unit within Kubernetes is called a pod. So these are these boxes here. So we have a Swarm pod, which consists of Swarm itself, which is a container. And there's another container on the side, which is the Jaeger agent. So this is collecting traces from our Swarm container. And also then forwarding these traces to the Jaeger collector on the right side, which can then store this on some data store. And we also have a UI to query the traces. So these are traces. And then, of course, for metrics, Swarm has it generates a lot of metrics, and you can forward these metrics to InfluxDB. So we have a separate port for that, and on InfluxDB we want to visualize these metrics using some dashboards. That's why we have Grafana, and on the left side we have Capacitor. This is kind of the alerting tool that, based on some thresholds, you can generate alerts or warnings so that you can identify problems quickly. And this is all this is within a single package. So let's go to demo and showing you guys some code. That's not what I want to show. I just want to like explain you quickly what a Helm chart is, like in simple terms. So we have this repository where we store all our Helm charts. There's one for our like Swarm private deployments of a private cluster. It has like this requirements file which contains like dependencies. For example, we see here we need InfluxDB, we need this capacitor, we need the Jaeger. This is just like a reference to like other Helm charts. And then at the end, Helm, what it is, it's just like a bunch of templates, like resource definitions within Kubernetes, and you see it's basically templates. And all these values within these templates that are defined here, you can override them, and the defaults are defined within this values.yaml. And whenever you like use Helm to install something, these will be the default values, but you can override this with your custom values file. And this is mainly how we kind of use Swarm, like deploy Swarm currently. Another thing that we use on top of Helm is Helm's man. So what if you want to manage multiple Helm deployments? You can do it via the command line, but at some point it will get annoying. So for that we have Helm's man. We have this repository that it's open source. It has the definitions of our staging cluster. Let's have a look at one of the definitions. So you can see we want to deploy some apps. One of them is our private Swarm cluster. We just say what chart we want to use, basically here, the Ethersphere Swarm private chart. And then we kind of provide like a reference to our custom files where we are overwriting all the configuration. Configuration can be, for example, saying which Docker image we want to run. For example, recently we released 0.4, so there is a Docker image for 0.4. Together with the Swarm deployment, we also have like smoke tests, which are then targeting this other Swarm deployment. And the good thing about this, once you have like this file created and you configured everything properly, running then a Swarm cluster is one command. Which will bring like up all those components that you saw on the graph previously. Good. Then once you deploy your cluster, you want to access it somehow. To make it easier, we also have like a web server in front, like a reverse proxy that can target your individual Swarm containers or just load balance across them. This is an example. I mean, in here I'm just accessing like one of the containers, number 23, within a deployment that Anton has. I can easily change this to any other one, or I don't even care which one I'm targeting. I just remove this number and I'm just load balancing across one of them. Yeah, and this, again, it's like one command and all this magic comes up and you have this working. So this is very good for developers because you just provide them like an example on how to run like a 100-node cluster, and then they can reuse this and just change some little configuration to test stuff. So this is like ingress, how to access, and then an important part that Anton mentioned are like then the metrics, like how we visualize this. Maybe you want to talk a bit about this?
Yeah, so basically, once you run this deployment with Grafana, we also automatically provision all the dashboards that we use internally to monitor our deployments and monitor our tests, which basically is a lot of dashboards which kind of change often because we are developing Swarm, but I'll just show a few of them. For example, the peer-to-peer dashboard. So this is a deployment that we started yesterday. I mean, currently it just shows the last 30 minutes, but you can see like the total number of peer-to-peer messages, the number of registered peers per individual container. Then you can see how fast some of those requests are, and then you can see all the individual protocols. For example, this one is not running PSS, so you don't see anything here, but you can see all the message exchanges and the number of messages sent between the actual wire protocol messages, which is very helpful when you debug stuff. For example, one thing that is interesting is that we know here that we're running smoke tests every 10 minutes. And when I say smoke tests, currently these are the very simple ones that we run. You just upload a file every 10 minutes and you try to download it from a different random node in the network. So it's kind of interesting why we're seeing, counters for those messages all the time. And that's actually a known bug that we have in Swarm right now that we're going to fix for the next release. But it's immediately visible that you're not if you're building on this protocol, you know that you shouldn't really be seeing those message exchanges at that point in time. And it's, very helpful. Other dashboards that automatically get provisioned for you, for example, you can see the smoke tests. Like we can see the last, 12 hours. We can see all the runs, how long it took to upload the given file, how long it took to download it, how our chunks synced across the deployment so that we see what kind of overhead we have, and other interesting information that you can see basically what your Swarm node, and in this case, your whole deployment is actually doing. The local store one, for example, shows you the data usage on the given nodes, the number of get, put calls, timers, and all other interesting information so that you can further build on Swarm. And now Rafael is going to talk a bit about the logs. One thing that I want to mention is that you automatically get this every time that you run those Helm charts. So even if you don't have a clue how to run, let's say, Grafana, because you've never used it before, this gets deployed for you. And it's quite handy as a tool to understand what's going on.
That's right. That was a very good point. Then after metrics, logs. So all these different containers running within Kubernetes, they are generating logs. We are sending all the logs that containers generate to Elasticsearch, and then we can visualize everything within here on Kibana. We can filter like by namespaces. I see, for example, that Elad is running a deployment here that is generating logs, so I could just filter his namespace to just get his containers, and then you can start filtering by specific containers or different applications, whatever. So I mean, that's mainly it about logs. Then also important is the tracing part. Let's see if this works. Let's just try to upload a file to Anton's deployment. I'm just going to upload some image. Okay, we got here the hash, and now I'm just going to download it from another node. Okay, so we uploaded something, we downloaded it. There should be some traces. We downloaded it from node 1. So let me just refresh the page to be sure that this works. Downloaded it from node 1. So I expect there's a HTTP get BZZ. And let's try last hour, find traces. Okay.
That's actually the redirect because you didn't add the slash in the end. So the first one is the redirect and the second one is the actual trace.
Right.
And then if you collapse them, okay, that's not the key I expected. Anyway, I mean, it's very useful to learn the shortcuts of Jaeger because you can then collapse and expand all the traces. Otherwise, it's a bit overwhelming. But right now, you can see that this node 1 is actually fetching some of the content from node 63, and then it's fetching it from node 46. And you can also see how long different messages actually took. You can also attach logs to those individual spans, and you can see, basically you can trace from where in the code that happened. I mean, you can, for example, validate that your requests are going closer to the chunk and not just fetching it from a random node. Basically, it's very useful tool to visualize how different protocols work within Swarm. Yeah, that's pretty much it for the traces.
Yeah, That's traces. Now let's try something else. So I already prepared like a deployment of, I don't even know, swarm demo get stateful set. Let me just verify. Okay, we have like a cluster deployed with 100 nodes running. I already prepared this so that we don't lose like 1 minute. That's the time it takes to have this running here. And let's just try to here print out the Cademlia table here, BTC Hive on one of the nodes. So here we can see, like if you check the population, we know about 100 nodes and we are connected to 15. And now let's try to scale this to 1,000 to see what happens. And you guys saw this was one command. I didn't have to care about statically defining where to run stuff and so on. This was very simple. Now it's going to take, well, it's not instant. You won't see like 1,000 nodes running. It takes some time even like to start a container. So the container images have to be downloaded. They have to be the starting is quite quick, but downloading images and so on takes some time. And then also swarm starting. We are not persisting data, so we are generating keys for every swarm node, so this also takes some time. But you already can see that it's increasing, so we have 184 nodes right now. We are checking, I think, every 5 seconds on changes here. So yeah, we just leave this 350. So we just leave this running and continue on the talk. And at the end, we will check if this worked out. Let's go back to the slides. So,
yeah, one thing to mention is that everyone on the team has access to this cluster environment, so everyone basically can start their own deployments in their own namespaces. And metrics, logs, they're kind of isolated. So if I run a deployment, it doesn't interfere with the deployment he's running or somebody else on the team. And yeah, the autoscalers make sure that we're also not wasting resources on Amazon. So basically those machines that are going to start up right now are spot instances, which are like 5 times cheaper than the on-demand instances. And they will shut down after like 5 to 10 minutes after we shut down this 1,000 node deployment. So that's also quite cost effective.
Right. And before we get to the 1,000, I want to mention like some next steps, some improvements that we want to do. So currently, like applying these, developers do this manually. Like even though it's one command, they kind of do this manually. What we want to have is to integrate this into our development lifecycle. That, for example, a cluster gets automatically spawned up during a pull request, and we report like back the result of the smoke tests to that pull request. And for example, if something goes wrong there, the developer should also have the ability to then further on debug on the current deployed cluster to figure out where the problem is. Also another one we have, so we have this simulation framework. We want to create like an adapter there so that we have the possibility of just spawning up directly Kubernetes pods running a swarm container. And way more in the future, I mean, all this metrics, traces stuff, this works very well on private deployments, but you might ask yourself, okay, what about the public network? How can we debug that? Well, that's a very complex problem, and in my opinion, for that in the future, we will need like some friends. So people that run nodes, we will probably try to collect anonymized metrics. This is, of course, opt-in. And yeah, those are some goals.
Yeah, about the anonymized metrics, yeah, Peter from the Get team actually has a nice tool that basically allows you to send your metrics over Tor to a centralized server. So that would be one way of doing it. For example, we wouldn't have a clue where those metrics are coming from, but we would still collect data from the community and have an idea of how the network works.
And yeah, it worked. So we have 1,000 swarm nodes running. I'm just going to scale this up even more for fun. While there are like questions, I don't know what the limit is right now. And
So one other important thing to mention from a developer perspective is that even though this is well automated compared to what we had before, it's still not a very tight feedback loop. So unless you're familiar with the system, I mean, obviously there is a learning curve, but it's not as fast as, just running Go test on your local environment. So what we want to do, Rafael mentioned it as next steps. We have the simulation framework. It's very useful, and we want to move some of those tools back to your local machine so that you can have a similar feedback loop with, let's say, 4 or 5 nodes. Because usually that's enough to run a bunch of unit tests and to have a very tight feedback loop and debug and develop protocols on Swarm. Once you're there, then you can run your tests on much larger deployments and basically have a better safety net with end-to-end smoke tests and the rest. Right now we are at a point where the simulation framework can do some of this stuff on your local machine, but it's not that easy. For example, grepping for locks is difficult, interactively checking instances after the simulation has finished is also difficult, whereas with this environment it's actually very easy.
Okay, just last test, let's upload a file to this 1000 node cluster. Now it's actually 1184. Okay, I just uploaded an image, got the hash. Let's open the web. So I uploaded it to node 0. Let's just access it on node, I don't know, 55. I'm gonna put the hash here. Go. And one last test. What was the address?
Swarm summit.test, if it's the same hash. Yeah, this is from yesterday.
So you can see that ENS resolution on Robston also works, which is pointing to that hash that we previously uploaded. And I think that's it. Do you have any questions? We have, I guess, some minutes.
Okay, is there any question?